Hello there, my sunshines. Today we are taking notes again. Today is January 10th when you should be writing these notes down. Alright, so let's go ahead and take a look at what those two characteristics I was talking about yesterday about proportional versus non-proportional. I don't actually really mean non-proportional, I just mean linear relationships, okay? Alright, well let's get into this. Proportional versus linear functions. Remember, a function compares every input has exactly one output, okay? So proportional and linear functions are both functions. Proportional is a specific function and linear is a broader function. Okay. Remember our direct variation equation from yesterday, y equals kx or y equals mx. Proportional relationships have direct variation and they pass through the origin. That is important. That's number one. They pass through the origin. Non-proportional or linear, any linear function that cannot be expressed by the y equals kx. And I will show you by graphs what I mean by this. So here we have this big picture of linear equations, okay? And then I'm trying to tell you, here's the proportional. So we have linear, proportional, which is actually called direct variation, okay? Proportional relationships are linear, but linear is not also, does not always mean direct variation, okay? Big picture, here's what we're trying to see. Proportional relationships go through the origin, and second, they're a straight line. Okay, one, they go through the origin, two, they're a straight line. That's your essential question from yesterday, right there. One, they go through the origin. Two, they have a straight line. So one, two characteristics. While linear only has one, which is number two. They're straight line. They don't always go through the origin, and that's okay. This is a transformation that we've been talking about, like we're translating it. Okay, we're moving the lines up and down. Here we go. So, we're going to write the equation, the direct variation equation. This one has two characteristics. One goes through origin, goes through 0, 0, goes right here. This is the origin. Alright, and two, it's a line, a straight line. So this is that direct variation, meaning y equals kx is how we're filling this in. So let's fill in our table. -1 is down 2. We have 0, 0. 1 goes up 2, and 2 goes up 1, 2, 3, 4. Alright, so all we're thinking is, since it goes through the origin and it's a straight line, what times -1 is -2? What times 0 is 0? What times 1 is 2? Here's where we're really going to be looking, because k is equal to 2. 2 times 2 is 4. 1 times 2 is 2. 0 times 2 is 0. -1 times 2 is -2. So y equals 2x. We find it with our unit rate, and we're good to go. Big picture, here's what I need you to know. This is proportional, so the pattern means it's a multiple, and we got this. Example 2. Write the equation for the graph. Okay, did this go through the origin? No. So this is just a linear, just a line. We can't use y equals kx for this one. Cannot use y equals kx because it does not go through 0, 0. We're going to use a different type of equation, but let's go ahead and make our table so we can see what the pattern is, okay? Remember, I want you guys to practice this thought process of finding patterns because it's super important. We're not going to get anywhere if we don't practice this trial and error process here. Let's start off with what we do know. We do that know that -1, right here is -1, goes down 1, 2, 3, goes down 3. We know that 0 is right here, goes down 1. We know that 1 goes up 1, and 2 goes up 1, 2, 3. Alright, so what is our pattern going on here? We know that we're going up by 2, up by 2, up by 2. Alright, so 1 plus 2 is 3. That's not it. Guessing. What could we do to get 1 to go back to 1, to get 2 to go to 3? 2 times 1 is 2, plus 1 is 3, plus 1? No. We need to have this pattern of going up by 2, up by 2. Alright, well we know that the unit rate right here is right here, but it's not proportional. I would like you guys to do your best equation skills here because we are going to talk about how to make the equation quickly, easily, accurately next week. Okay, you guys go ahead and try to make your own equation. I want to focus in on the fact that linear does not go through the origin. Okay, linear does not go through the origin. It doesn't have to go through the origin, while proportional does not. Oh, sorry, proportional has to go through the origin. Proportional has to, linear does not. Alright, example 3. The total snowfall each hour of a winter storm is shown in the table below. Okay? Would this, at hour 0, have 0 snowfall? That's my first question. If you're answering yes, and this is proportional, and we can make the equation very quickly. If the answer is no, then we're going to learn the easy way next week. I think at hour 0, before it even starts, the winter storm starts, that there's no snowfall on the ground, and so I'm going to say that 0, 0 does exist in this, okay? Let's see what happens when we look at that. 1 times 1.65 is 1.65. Let's do 1.65 times 2. 1.65 times 2. 3.3. Yep, so this is that proportional one. This is a direct variation, meaning these numbers are being all multiplied by 1.65. Our equation is y equals 1.65x. Each hour it snows 1.65 inches. Describe the relationship between hours and snow, inches of snow. Each hour, 1.65 inches of snow falls. There we go. That's all I gotta be able to do for that one. Don't stress on me yet. Alright, so that's the end of today's lesson. Now, I want to talk about tomorrow and your quiz. Tomorrow, quiz. Your quiz will be over just going from that equation, a given equation. I'm going to give you an equation. You're going to make the table for it, and then you're going to graph it. That's all I need you to be able to do tomorrow's quiz. So right now, I need you to go grab that review worksheet, okay, and start review worksheet. Hopefully you can get this done in class and not have to worry about homework, and you can ask Ms. Shepherd all of your questions. Right now, I need you to start that review worksheet. There's no checkpoint for you to take today, okay? There is no essential question for today. I just wanted to briefly talk about how we are moving a line around on a graph. All right. Good luck, guys. I hope you do well on your quiz tomorrow.